Hello everyone, my name is Billy Goodall, and today I'm going to give a presentation on our water design project. This project was based on our class ECE 330, Environmental Engineering. So getting into the project, the basic main objective of the project was to design, build, and operate a simple water treatment plant. The water had to be extracted from Mount Union's pond. It had to meet the EPA National Primary Drinking Water Regulations, which I'll get into later. We had a $200 budget for any materials or supplies that were needed, and the amount of water to treat was up to us, because what the basic outcome was Dr. Tritico was requiring that he would drink our treated water for a week or 7 days. So we decided to come up with that we would give him at least a gallon of water a day to drink, but to be safe, we thought that 10 gallons would be the safe number. So keep in mind, we're treating roughly 10 gallons of water here. So getting into our design process. So first, we had to extract the water from Mount Union's pond. The way we did this, we basically got 5-gallon buckets, we went to the pond, we dunked them in, and we took 5 gallons in each bucket. The next thing we did was we used a coarse filter. Now we had 2 coarse filters. One was a pillowcase filled up with rocks, and the other was one that we purchased online, which allowed particles which didn't allow particles as small as 50 micron to pass through. Now keep in mind that a coarse filter, really the only main use of a coarse filter is to take away the big stuff, the big maybe leaves or any big particles that are suspended in the water. So after we ran through the coarse filter, we put the water in a mixing tank and we added powder activated carbon. Now powder activated carbon is a special substance. When you put it in, which we calculated the right amount of powder activated carbon to put into the water, we stirred it up for roughly 15 minutes, and what happens is any particles that are within the water will stick to the powder activated carbon, and they will eventually settle to the bottom. So we let it mix in this mixer for roughly 15 minutes, and then we let it settle for roughly a week to let all the powder activated carbon settle to the bottom. So once we finished this step, we moved on to our fine filter. Now our fine filter was also purchased, and this allows anything smaller than 0.1 micron, which is microscopic. So basically what this fine filter would do is it was guaranteed to kill 99.9% bacteria, and it would also remove all the powder activated carbon from the water that was placed in the previous step. And finally, we added chlorine dioxide tablets to destroy any bacteria or any microorganisms within the water. Now I talked about the EPA regulations. So basically what this comes down to is the turbidity must be less than 1 NTU, which turbidity is basically the cloudiness of the water. The microorganisms, there can be no microorganisms within the water. The chlorine level must be from 0.2 milligrams per liter to 4 milligrams per liter. The total hardness must be less than 150 milligrams of CaCO3, and the pH has to be within the range of 6.5 to 8.5. So getting into the turbidity. Like I said, it's basically the cloudiness of the water. Right here is a turbidity meter, and right here is the vial. So basically, after we treated our water, we would place our water in this vial, and after configuring this, we would place the vial in there and it would let us know. And as I said, the turbidity had to be less than 1 NTU. Microorganisms, there should be none present. The way you test microorganisms is by using these agar petri dishes. And how this works is, this is an aspirator right here, and we place our water in this cup, and we put a filter here, and we let the water run down through this little paper filter, and then we'll place the paper filter in here in the agar dishes, petri dishes, and we'll let it incubate for 24 hours. And then the next day you look at it and you'll be able to see if there's any microorganisms present or not. The chlorine level, the way we tested this is we just simply purchased chlorine strips right here, and you can see this bottle has a range on it, and you can see that this color is like a light tinted blue, and we were in between 0.2 and 0.4, so we were within the recommended range, as it says here, 0.2 to 4 milligrams per liter. The total hardness, this was the total hardness kit. Came with the directions. It's kind of complex, but if you can follow directions, it's not too bad. Basically, it's basically a titration. You're just waiting for the water to change a certain color, and then that many drops will tell you what your hardness is. And as I said, this has to be less than 150 milligrams of CaCO3. The pH level, within 6.5 to 8.5. Here's a picture of a pH meter. You configure it with already set pH bases. And basically what you do is you put this little rod in the water and you would let it read the pH. So basically, here's the end results from our testing. Our turbidity was found to be 0.25 NTU, which was under the 1 NTU. Microorganisms, we had none in the agar petri dishes. Our chlorine level was found to be 0.4 milligrams per liter. And our total hardness was 120 milligrams as CaCO3, and our pH came out to be 6.83. So as you can see, all of our tests that need to be within the EPA standards fell within the standards. So basically, I'm gonna get down to the cost breakdown. These were the items that we purchased. So I had filter pump broken. Our first filter that we purchased actually ended up breaking because after we filter, we could still notice some PAC in the water. So we took it apart and we realized, well, this is a broken filter. So then we had to purchase a second one. And the second one actually worked great. I mean, the water came out a lot clearer. You could just tell that this was the filter, or this fine filter was working perfect. We bought chlorine dioxide tablets. We bought 2 boxes of those because for every gallon we needed 4 tablets, so we needed 40 tablets total, and I think they sold 24 a piece in each box. So we bought 2 boxes of those. The powder activated carbon came out to be $24.95. The coarse filter that I talked about, which was 50 microns, that it didn't really do anything, but it took out all the big stuff. And then we also had shipping, and so our total came out to be $141.71, which was under our budget of $200. Basically evaluating how we did on this project, we met all the EPA standards. Dr. Tritica, we provided him enough water so he could drink for the full week, and he also didn't get sick. That would have been a big one. If he would have got sick, that means we did something wrong, because you should not be getting sick from drinking water. Breaking it down, we roughly cured a gallon for $18, which really isn't the best scenario, but because of the first filter breaking, it kind of hurt us in that part. And it roughly took us over a month to treat 10 gallons of water, which really isn't that efficient compared to the big water plants that treat thousands upon thousands of gallons per day. So where can we improve? Definitely our efficiency. A large fine filter would have been huge, because the fine filter we got was very small. It was basically meant for your own personal use, not really treating a bunch of water. So a large fine filter would have reduced a bunch of time. And also transferring from tank to tank was tough. We had to use beakers, we had to use cups. You know, if we would have had pipes to transfer from the water from tank to tank, from mixing tank to our cooler, it would have went a lot quicker. And obviously our cost wasn't the best, and we could have figured out a cost by maybe buying in bulk. If we wanted to really put it on a larger scale, maybe treat 20 gallons or 30 gallons, we would have bought the materials in a bigger bulk to reduce the cost. And here's my references. Thank you. Is there any questions?